Ready? Okay, good morning everybody. This is Jacob Arnold and Eric Raposi over here. John Espiritu, my name is Lauren Burton, and this morning we're going to be presenting to you Personal Mass Transit System Design and Funding. Our sponsor is Ballard Company. Our advisor is Professor Wayne Davis, and our company contact is Lon Ballard. So, just a quick overview of our presentation. I'll be going through the project introduction as well as the common statement and team objectives. John will talk to you about the transportation problems and solution methods and plans. Jacob will talk about our proposed solutions and implementation challenges. Eric will talk to you about our funding process, our economic analysis, and conclusions and recommendations, and we'll finish off with a question and answer session at the end of our presentation. So, with that, here we go. So, who is Lon Ballard? Lon Ballard is in the middle there. The image, the rest of the people in that image are the Spira crew, and the vehicle you see is the Spira car. It is a very fuel-efficient, cost-effective vehicle. Interesting project, but unfortunately it does not relate to what we've been working on this semester.
Who's that, brother?
Brother. Yeah. And I believe they're in Thailand, in that picture?
Yeah.
Which explains the child. So, what is Ballard's vision? Well, I think a video would explain it better than I can, so we'll play this while I'm talking. Short-term vision for the personal mass transit system is to have U of I as a prototype for the system. It'll be very similar to what you see in this video. Instead of the cars being on top of the tracks, they'll be hanging from the track. Other than that, pretty much identical to this system. This is actually the Ultra PRT system, which is a system that's in development and has been used in a couple places already. So it's a real working system, even though this is computer-generated rendering. So Ballard's long-term vision is to have a high-speed system that would use lots of the same principles as this system, but it would connect major destinations and cities across the country. It's a long-term vision though, so it would take a while to implement. The economic impact of this system would be dispersed. It would create jobs for the construction and operation of the system. It would promote the development of businesses, and it has the possibility of bringing in revenue for city and state governments. So, where do we come into this project? We will be determining the steps for implementation, forming local partnerships with the cities of Champaign, Urbana, and University of Illinois. We will be finding funding sources from federal government, and by the end of the semester we will complete a funding proposal. So, how exactly are we going to accomplish those goals? We'll analyze transportation problems, which John will talk about in a minute. Research the PMT technology to determine whether or not it's feasible to have a system on campus. We'll establish context, gain support, and create partnerships, as I just mentioned. And analyze the feasibility of a PMT system. Conceptualize system implementation, for example, where will these tracks be located if they were on campus. We will research the funding process, prepare and submit a funding proposal, and analyze the potential economic impact of the system. With that, I'll pass it off to John.
All right, thank you, Lauren. From our discussion with various people from the University, Urbana, and Champaign, we found out that these are the current and future concerns of them. We find out that they're trying to reduce traffic congestion, and they're also trying to improve pedestrian safety and wellness. As a consequence, they're improving the street conditions, and they're adding more sidewalks. Also at night, they're improving the lighting on the streets and also adding more buses. Also, they're trying to improve handicap accessibility for transit systems. Currently, the buses have that kneeling feature, so they can load the handicapped passengers. And we're going to implement that in the PMT through elevators. And they're trying to reduce energy consumption and improve sustainability. And also in the future, they're moving parking to the outskirts of campus. So an effect will be an increase of transportation to and from campus, and there will be a further increase in the flux of transportation during peak hours. As in the following slide, you can see that there's a lot of passengers at 9 o'clock and also in the middle of the day and also at the end of the day, right there.
This is from TD, local bus service.
Yeah, so currently the buses usually take It usually takes 2 buses to load the passengers at 9 o'clock, so it's going to be more of a problem if the parking is moved outside of campus. So, will a PMT system solve the transportation problems? Well, to find out we met with various people, as mentioned in the previous slides, to find out their needs and concerns. We researched about the current PMT technology that is currently in place in West Virginia, and also the one that is being built in Santa Cruz. Also, we're developing a PMT solution that will meet the needs and solve the transportation problems of the university and the two cities. So the concept that will promote the PMT system that we found out where they did a corridor study a while back that analyzes the transportation along University Avenue between Champaign and Urbana. And our PMT system aims to connect the two cities through University Avenue. Also, we look into the climate action plan that was signed last May, which aims for the university to be carbon neutral by 2050. And our system, it has zero carbon emissions, which will coincide with that. Also, our system is pro-sustainability, and its overhead structure will improve safety and reduce these crash numbers and pedestrian crashes. You know, a fourth of these result into injuries, and 3 persons died from these pedestrian crashes. So we're trying to reduce that to improve. We're going to improve the safety of this system, and then we're promoting development because a transportation system like this would entice businesses to set up and promote growth. And here's Jake to further discuss our solutions. Thank you.
As you can see here, here's one of our proposed routes. It's a basic campus loop, and our estimates make it out to be about 4 miles. It mostly serves students being a campus loop, and as you can see, these circles represent some of the possible locations for stops, which would hit high-demand areas such as the residence halls, Memorial Stadium, by the bookstore here at Transit Plaza, which would transfer to different buses.
Does it go beyond Kirby? Because how it does?
Yeah. This is another proposed solution we have, which would also branch out to other areas in the community. It would serve students as well as the residents. And as you can see here, here is Orchard Downs, one of the locations that was suggested by Libby Tyler, the city planner of Urbana. And she suggested having areas, links like this to promote development. And as you can see, that we go back to the 2 downtown areas. The other area she suggested was a route to Research Park, and that was also suggested by some other people we met with. And finally, as you can see, the connection here down University Avenue would coincide directly with the corridor study that was done in 2007, connecting the 2 downtown areas. So we did a cost analysis on these 3 system routes, as well as a 1 mile long track that could possibly be used in the future to connect these outlying parking lots that would move to the outskirts of campus. So to get our capital cost, as well as some of these other estimates, we looked at similar systems such as the Morgantown PRT, as well as the Ultra PRT. To get our capital cost, we found an average cost of track length per mile and multiplied it by the track length that we found for these estimates. To get our annual utilization, we looked at utilizations of existing systems and utilization predictions from other studies, and we scaled that by population. And to also get a better idea, make sure these numbers worked right, we took a certain percentage of the MTD's utilization, and just to make sure that these were reasonable estimates. To get our annual operating revenue, we set a cap at $1 per ride, which is what MTD costs. And from that, we also got our annual operating cost, which we converted numbers for the operating cost of the similar systems into the cost per passenger mile, and then we can multiply that again by our track length and our utilization. And from that, we were able to get our annual operating income as well as the rate of return. As you can see, our income is positive, but unfortunately, the rate of return turned out to be negative. But we would need to get some sort of funding to cover these capital costs in order to make this a worthwhile project. As you can see from our first analysis, we see that the basic campus loop has the best rate of return overall. So not only do we have to worry about the economic feasibility of systems such as these.
One slide.
Yes.
So that assumes $1 per traveler, is it?
Yes.
And you try to see how sensitive that is to increase. So So I imagine that you could...
We could change it, yes.
Have you guys seen how...
We just set it at $1 to coincide with MTDs. We could lower it, but I don't think we could go over it.
Does that, I mean, the MTD is, you know, all the students and such,
Yeah.
right? And they make the contract with the local.
Yeah.
Right.